All right, so we were just I was just talking about this in the last video. So at the equator, the hot moist air um, will rise. That's because of the low pressure, and then as the air goes north and south from the equator. By the way, the air doesn't usually cross the equator at all. And what will happen is that moist air, it'll rain. And in fact, between 0 and just above the equator and below the equator to about, I don't know, 20 degrees or so on either side, you get the rainforests, right? You get all this, this incredible amounts of rain. And then, so the air, is remember, this is a convection zone, and so the air cools off, and so it gets high pressure, and then it begins to fall, and of course that's right around 30 degrees north and south, and that's why you have the great deserts of the world. Um, they don't get very much moisture at all at 30 degrees above and below the equator. All right, so that's and then above for between 30 degrees and 60 degrees, both north and south. These are these are areas where this is actually where you get a lot of the United States, for example, in this area here, and so you have relatively moderate fluctuations in rain and um, so you can grow stuff here, right? Whereas right at 30 degrees, you get a lot of it's incredibly dry there, and at negative 30 degrees, it's incredibly dry. All right, so anyhow, here, let's keep moving here. So I think I covered this. I already covered this. Prevailing wind is westerly. It blows from west to east. Westerly winds contribute to cooling. So I don't. Let's see. Did I answer this one? The prevailing winds, where those is deflected. Oh yeah, to the right in the northern hemisphere and to the left in the southern hemisphere. All right, I did do that in the last video. All right, so this one I don't think I've answered yet. The prevailing winds in North America are westerly. So remember, westerly means that this is the origin. It originates in the west and heads towards the east. Right. So those are the prevailing winds that cross the United States, and the westerly contributes to cooling of the cooling of the west coast. Uh, Remember, the westerlies. It's not just North America. It's out in the Pacific Ocean, heading towards the west coast. So anyhow, it contributes to the cooling of the west coast in the winter, and warming in the summer. The cooling in the no, that can't be it, right? Because it's not gonna cool it more in the winter. So cooling in the summer and warming in the winter. That actually sounds right. Let's see, what's the next answer? So that the temperature is the same. Oh, no, that's not true. Making the temperature variations more extreme. No. So it cools the western United States in the summertime and warms it slightly in the wintertime. All right, so, oops. So there it is. All right. So now, we talked about this, about the Coriolis effect on the wind, and now we're going to talk a little bit about the currents in the ocean. All right. So right at the surface so we basically are going to divide the ocean into different zones, right? So right at the surface, then there's this transition zone, and then there's the deep zone. Okay, but just to let you know, these currents in the deep zone can take thousands of years for the current to complete, one cycle for. Okay, but at the surface, you're really dealing with what's going on with the wind. The wind is really what's driving the surface. All right, so the surface currents are created by the wind. The surface ocean currents are created in the direction of the prevailing wind, except, of course, we're on a spinning planet. All right, so because we're on a spinning planet, there is this thing. Well, it's not a thing. It's because of the Coriolis effect, or the Coriolis force, that it causes. You would think that the water current would go in the same direction as the wind, but because of the Coriolis effect, there is this deflection up to 45 degrees with respect to the direction of the wind, and that's called the Ekman transport. Ekman was the person who originally discovered this, or proposed it, to propose why it was this. And so this Ekman transport will deflect the current from up, as I said here, up to about 45 degrees, and it's most prevalent at the surface, and then it gets less and less as you get further and further down. So you get down 100 meters or so, and it's not as the length of the arrow is not as prevalent. All right, so but notice there's this curl, this spiral that goes on within the ocean. That's going to become really important to us in just a moment. All right, so factors that influence the ocean currents: for short distances, it's the wind. For long distances, it's the Coriolis force that comes into play, and you get those Ekman, the Ekman transport. All right, Coriolis effect at the surface causes it to twist and turn in semicircles called gyres. These gyres are so in the northern hemisphere, the gyre is rotating clockwise. I know it's a lot to remember. So in the northern hemisphere, it all comes from the Coriolis effect. So the gyre is basically rotating water current right towards the surface of the ocean. And so in the northern hemisphere, it is going clockwise. In the southern hemisphere, the gyre rotates counterclockwise. All right, so this is a good example of it. There's Florida right there, and so this is these are rotating gyres in the northern hemisphere, are spinning clockwise. This is what the Gulf Stream. This is exactly what the Gulf Stream is doing, right? Carrying hot water towards the towards England and the rest of, or part of Europe anyway. So this is years in which the trade winds. So remember, we had that we talked about the trade winds. Here, let's go back to this picture right here. Oops, it's back quite a bit. So the trade winds, right? So the trade winds are between between the equator and 0 and 30 degrees north, and the equator and 30 degrees south, right? And so the trade winds are moving from the east to the west in the northern hemisphere, and from the west from the east to the west also in the southern hemisphere as well. Okay, so these are the trade winds. All right, so here, let's go back to where we were. Sorry to skip. All right, so now what that does is that you can see that there is this overall convective current that takes place in the ocean, right? So this is this is the example that we see is the this is the water. So I'll get into this in just a minute. This has to do with in the deep oceans, um, and in the shallow, the relatively shallow ocean. Uh, so you can follow this path. Um, so this is here. So this is um, the, the direction of these convective currents. All right, so this is one of the things that happens is in years when the trade winds are not as strong. So remember, the trade winds are between 0 and 30 degrees. Those years are called the El Nino years. So in the El Nino years, it'll influence the climate in the Pacific, in the Pacific Ocean, and it'll actually cause the climate to change, um, across the country to some extent. All right, so deep waters are driven by not by winds but by gravity. Okay, so polar wind freezes. Polar water freezes, and when it freezes, what happens, of course, is the fresh water. I mean, there's of course salt water in the ocean, but only the salt won't freeze. And so what happens is the ice, which is sitting on the top of the ocean, when it freezes, that causes the saltiness of the water below the icebergs to be greater, and that's called salinity. So the salinity goes up, and because that is more dense, that high salinity water will head towards the towards the bottom. So this cold, salty water continues to sink to the ocean bottom. The sinking water pushes deep water out of the way and causes the bottom water to flow outward. And these are these currents that I was just talking about. Okay, this is exactly what takes place. All right. So the combination of deep water mixing and the tidal stirring this is actually a really slow process. As it says here, it can take thousands of years for these belts, these conveyor belts, if you will, but to complete one cycle. But what's happening is that deep water is bringing nutrients, or it's moving nutrients at the bottom of the ocean all around the ocean, and that's very helpful to life forms, especially where the water from the deep ocean rises, you'll have all sorts of marine life and so forth. All right, so that's about it for this chapter. Well, I just wanted to go over this as well, or in a little bit more detail. So for El Nino, basically what's happening is you remember we're talking about the oceans. You get warmer and wetter weather in the east, on the eastern side of the Pacific, and when you have a strong El Nino, you get a lot of rain, and flooding can occur in coastal South America and in California. Okay, so that's this El Nino condition. All right, so you might have heard of that before. All right, and that's about it for chapter 24. The next thing we're going to do is look at a little bit of what's called optics. So when light interacts with matter, and how the light changes. All right, very good.